CIT 226, Data Integrity and Security, and the book we are covering is Database Security. We covered up to using HTTP for different settings, and then we'll try to understand the vulnerability through errors. That if there are any errors shown, if someone is trying to perform a SQL injection operation, what would be the scenario? The malicious code is not executed until it reaches the database. So if someone is trying to run a query remotely and they are trying to get some information out of the database, it's not executed unless it is reached the database, because that's where it would get the information from. Nothing gets in the way of returning unauthorized results. Administrators testing the environment may be presented with errors. Scripting language determines how to present the error. Now, if there is an error message, how deep you want the message to appear. Sometimes the web servers are configured in a way that they'll give a error message which is not too specific. For example, if a user is not able to authenticate, or if you're trying to get some information from the database, if it's not able to fetch that information, it won't show you exactly what's the reason. Because if it's not properly handled and it's not able to reach the database, for example, the error message which would appear on the screen would show the exact path or the location of the database from where it's not able to reach the information. So you'll have to craft, or you'll have to write the code in a way that it shows the error, but it does not show a complete message or the exact cause of it. We usually configure the web servers in a way that they show the minimum response on the users if in case it's not able to reach the web server, or if the query is not working on the remote database. Now, it can be handled on the programming part, it can be handled on the web server part of what kind of messages you want to display on the screen. They called it user-friendly messages or the system messages. Now, usually these kind of warnings and error messages which are displayed on the screen are enabled for the programmers or the database administrators during the testing phase, so that if they are getting an error while writing the application, they can exactly know that what's the exact reason of it. Need strong familiarity with the errors and how they are presented to find the vulnerabilities. Now, to ways to handle the error is code application scripting language to display specific error messages, that if something happens, craft a message which would display. Sometimes you see that if error message is coming on a website, it's giving you a code. So that code is only with the programmers or owner of that application, which they can read and decipher that what's the exact meaning of this error message which is appearing on the screen. So the end users who have not developed the application, they won't be able to understand that what's actually going on with this application. These can give intruders information about the system, because if it displays all that information, it might compromise the system. Configure web applications to respond with generic messages, not specific, that it's not working because of these things. Choose not to handle errors at web application. Allow HTTP to handle errors instead of server error. So application must not handle it, let it be handled by the web server itself. Now, the architecture is in a way that if web server is serving any application which is loaded on a web server and it's getting the information from the database, the main purpose of a web server is to get the information and to display it. It's not concerned about the queries, which kind of information is being written. That's the responsibility of the coders, that how they define it or how they catch the exceptions in the application when they are designing it. Using inference, professionals can note the error handling locations and messages content and use the information to minimize the vulnerabilities. So they'll find out exactly at what point the exact error message came and how they want to interpret it on the screen. First, understanding the typical Now the typical conditions with no error, like if you'll pass a query or you'll try to get the results, you'll get a condition but there will be no error messages shown. Example of typical or baseline configuration is online grocer, which allows the customers to search for purchase the products on yum.com. Customer chooses the category on the page on dairy and the URL appears as yum.com/index.asp and then category is equal to dairy. That's a typical ASP syntax where you can see that it's trying to get the information from the category dairy. So the end user, whoever is looking at the URL, can interpret that on the database there is a category dairy and there is a category which is called dairy, so there could be any other categories as well. So if the user would change the category from dairy to anything, for example fruits and vegetables or fish or meat or anything like that, they might be able to get some results directly from the database. Scripting language receives output URL to send the statement to the database requesting the dairy items. Now there is a way in the programming, if you are defining or you are writing the code yourself, you can suppress the exact information what it's exactly trying to get from the database in order to protect the data which is there in your database. Example of a typical baseline configuration on ASP is food category is equal to request category. Then SQL string is going to select star from products where food category is food category. And then it would execute, and the ASP in the background it would get the details select star from products where food category is equal to dairy. So by looking at the simple URL, you can easily understand that how it's getting the details from the database. Error can occur under the typical conditions. Response to the common user error, often overlooked because not viewed as thread. Assume administrator changes the URL manually from category dairy to hungry. ASP creates a statement that from the products where category is equal to hungry, and error will be generated if hungry is not a category of food or the system. Just like we read earlier that if you are trying to authenticate a user against a username and password, it should not show you exactly that the username is not right or the password is not right, because that gives them an idea that the username which you are trying to enter does not exist on the database. Sometimes they show a message that we don't accept numbers in the username. So you can understand as a hacker on the remote side that this particular application does not entertain any numbers in the username. So then they'll try all possible alphabets or word list or the typical usernames which are used in order to break into the system. Database returns error that column does not exist in the product table. Does not necessarily indicate an SQL injection vulnerability, but it exposes the basic vulnerability or security of your database. URL can be changed manually if database information is not hidden. Now, injection conditions with no error, successful injection, SQL injection executed without error returned from the database, often due to web application that do not filter the input. URLs do not hide the database information when testing the vulnerability. Successful injections need immediate attention. Who will catch the exceptions? Who will write the code behind the page whenever you have a form or anywhere you are trying to fetch the information is the programmer. So it's the programmer's responsibility to write the code in a way that it's not exposing any information. For example, the injections that they use is they put a statement which is always true. For example, they'll say 1 is equal to 1. We know it's always 1 is equal to 1. Then the syntax is different if you are testing for SQL injection on a server which is using SQL Server, MySQL or Oracle. The only difference in the syntax is that if in the URL after the complete path from where you're trying to get the information, if they'll write AB is equal to A plus B, and if it works, it means that in the back end it's a SQL Server running. If they'll try or AB as A and B in its own syntax, and it works, it exposes that the backend database is MySQL. And if it accepts as A backslashes and then B, and if it works, it means that it's Oracle. Now, most of the databases these days, or the applications which are written, they are smart enough to handle the SQL injections. But still, as we mentioned in network security and penetration testing, that there are some applications, legacy applications, which are still working on the old systems, or due to any reason they have not upgraded the database or the application itself, which falls in the category where anyone can easily conduct the SQL injection operations on that. Or, for example, statement that always returns false, as or 1 is equal to 2. You know 1 is not equal to 2, so that would be always false. Now, blind injections is attacks made with little to no knowledge of the system. Series of true and false SQL statements used to attempt to discover the information about the system difficult to detect due to their subtle nature. Now, assume the yum category, they are writing dairy or 1 is equal to 1. Now, the system would not stop it unless and until if it's defined that suppress any kind of false executions which takes place on the URL category if people are trying to get the information of the database. Now, it changes the URL results from SQL statement select star from products where food category dairy or 1 is equal to 1. So what it would do is that it would show all possible results which are there under the category of dairy, because 1 is equal to 1 is always true. Database returns everything from the products table. Single quote at the beginning of the statement is incorrect. Syntax to complete the statement. Double hashes at the end of the comment in SQL. All values of these are ignored. Now, you can see by these codes, usually this kind of information or these results are with the people who have good programming skills or who know how the queries are being executed in the back end. Only then they can try all those things. That's why most of the hackers are programmers, or they are too good in Linux operating systems where they know how to craft the exact attack and to launch it on the computers. Single quote characters can be inserted at different places to determine the vulnerability. If a database reacts in the same way with single quote added to the SQL statement as it reacts without the changes to the statement, indicates the vulnerability exists. Because if you are trying it with a single quote, you didn't get a result, you tried it, now that gave you two options. One is you got an idea that what kind of database is being used. The second thing is that the database is not secure enough to handle any kind of SQL injections. Syntax rules different between the SQL languages, so it's a bit different how you type it in the address. Now, some error messages are for the injection conditions with injection caused error that the vulnerability exists. Message differ between the database types, also depends on how environment application is built to handle the errors. Example of using an incorrect syntax to cause an error is that yum and then dairy or 1 is equal to 1, so it would search it from all products in the category and would give an error which would be returned as a syntax error due to double quotes appended at the SQL statement from the SQL injection. Now, attacker attempting to determine the dialect of the SQL type of the database and error handling on the web application would know that exactly what is it catching for. Now, this is about the URL category. There is another error messages that usually you get when you are trying to pass any parameters on the field where you enter details, for example, username and password. Now, that's not a URL category. That's a category in which you are typing in the details. Now, what they do is for SQL injection is that in the username, they'll write a code and then they'll give any password. Once it would check for the username, which is true for all conditions, it would let you log in regardless if you have a proper password or not. So, you'll have to catch it on those fields like post, get, and all those features which are there on a form, that if you are handling all these exceptions in the form itself or not, that the user must not be able to pass any parameters related to open-ended queries which would be executed instead of the username. Generic error messages often have no reference to type of the event that is returned the error, or no message will be presented at all. It poses a challenge to the intruder and the database administrator, difficult to determine if error has occurred in the database or the application. So you don't know the error is coming either from the application or from the database. If you are catching the exception at the application, or the exception is being handled at the database. Now, it's determined to define if error occurred in the database or the application. The rule out the error within application error handling system, administrator uses SQL statement that tests the database errors and returns. So if the database administrator is receiving complaints that we are trying to fetch this information and we are not getting the proper results, instead of going through the web application, he'll try it on the database itself with a query that if they are able to get the results by that specific query that he is passing to the database itself. Now, direct testing is attacker's next goal is test theories made during the inferential testing, actively execute the SQL injections. Now, active testing determines how an intruder is able to reach into the system, means to what extent unauthorized access was obtained, and determines how much data is available for view. Now, it prepares the administrator for removal of the injection. If a user passes something like a category is equal to dairy, and if he is getting all products related to dairy on its screen, it means that the programmers will have to craft it in a way that it would catch the exceptions when it is returning the error messages. And how can you program it in a way that the end users will not get the database information which is available in the database? Source code analysis is another way for locating the SQL injection problems. The second most common approach is to locate the SQL injection. Before the application moves to the production, the complete source code is being checked. Now, we'll talk about there is active checking and passive checking of it as well later in the chapter, but it requires less time and fewer resources than inferential or direct testing. Inferential testing, as I told you, that you will have the results of the queries which you had before, and then if you are trying to get an average of the difference between the output, you can get an idea that exactly how many new records were there. So you are not allowed to perform a query, but you can compare and contrast in order to get the exact results. Administrators work with application and developers, ensure the dynamic statements are being created and filtered without SQL vulnerability. So both of them work together, having information about the known problems with the SQL injection, making sure that the application, once it's open to the general public, does not have all those dynamic filters on. Determine how and where the input is being accepted, if it's accepted at the form level or it's being authenticated on the database and then coming back. Analyzing the source code can be a tedious and painstaking task, can take months if you want to check it chunk by chunk, and then you'll have to check that what kind of queries or information would be reflected from this application to the screen. One of the most effective ways to manage the SQL injection vulnerability is that tools are available to automate the process, which focus primarily on the security, weak locating the errors that SQL injections can exploit. So it has a set of known bad practices inside. So it would check your code against those things to verify that if you are not using those malpractices which would expose your database to the outside world. Now, dynamic analysis is attempt to find the vulnerabilities in the source code when it is being executed. That you have developed the application, it's hosted on the web server, users are using it at the end, and then you will be checking by passing different parameters to the application yourself that if it is responding with the kind of results which it is intent to show you on the screen, or it's giving you way too much information which is not required for that specific query. Now, static analysis efforts to find the problems while the program is inactive, means it's not on the server, requires less expense and fewer resources because you can check it by manual means or by the tools which they have defined in order to know the known vulnerabilities. more effective at identifying the vulnerabilities because it's not being executed on the web server so far. The problem areas are poorly written functions. If they are not as per the standards, these applications which you are using in order to check the code won't be able to identify it and highlight it or flag it as a known vulnerability in the application. Unverified user input, if someone has passed it on, it won't be able to check it. That's why it's very important for the programmers as well who are working on the web applications to be aware of all known attacks related to the weaknesses in the programming or the weaknesses on the database. Now, effective technique for reducing the SQL injection attack is to add filtering process between the user input and the dynamically created statement. So if a user puts an input in the search field, for example, if he is trying to search for dairy items, the output that he'll receive and the URL which would be displayed on the screen must be carefully handled, that it's not showing way too much information on the screen itself. Follow the path of variable back to its origin place where the user inputs the code. Determine whether the restrictions have been placed on the user input. Means the search field in which he is trying to search the items, he is not putting anything as or where 1 is equal to 1 or where b is equal to a plus b, so that it would show all the results which are there in a database. User inputs information into a text field of a web application, for example. Text field is with the name as tf name. Variable of the scripting language is defined as named and assigned to tf name as user input, which is going in the database as tf name. If user input is not verified to have appropriate set of characters, anything can be inserted into the text field and transferred directly to the SQL statement. So the field is not checking that if it's taking only the alphabets or numbers, or you'll bind it only for the specific kind of input. Just like in the databases, when you're designing a database in a field which is related to the text, you make sure that only text information goes in there. The information which is related to the ID numbers and numbers only, you know that there are no alphabets would be ever appearing in that. You'll define it as integer. It's the same policy which is there for the search fields or the login fields that you have on the forms, that you'll have to catch the exceptions on the application level. Consider how data is transferred from the form into the scripting language in HTTP, GET or POST. Now, unfortunately, if you have any simple page or a web page which is trying to get the information from the web server, if you'll see the source code of that page, you'll be able to see that if it's using HTTP, GET or POST in order to transfer the information or in order to communicate with the web server. Now, the research predefined function specific to the scripting language to ensure the validation is being applied. Now, tools for searching the source code are in different ways available to help facilitate the source code review. None are as effective and reliable as manual searching for it in the code itself. Three methods that they are talking about for analyzing the static source code is string-based pattern matching, then we have lexical token matching, and then data flow analysis. There are some key differences in them. How do we check it? The first of all, the string-based matching is a simple detecting tool. Searches for and locates user-defined strings and patterns within the source code. Whatever the user has defined, any kind of strings, it would search that in the code, and most basic of the three categories are produces the highest number of false results, that it is checking and is not able to get the result. Signatures are created for typical SQL injection variables, and string-based matching systems attempt to find the strings that matches these signatures. Just like we have hashes collected for the computers for the typical passwords in order to decrypt it, to know that what's the exact password. Now, it has the hashes for that, which would attempt for the strings. It would match the signatures with that. If it's matching with the code, it knows that something typical is coming on the web server which is trying to inject the SQL injection. Data flow analysis is the method for obtaining the information about way variables are used and defined in a program. So when it's data flow, it's about the variables which are used. Determine the dynamic behavior of the program by examining the static code of it. Data flow analysis control flows the graph which displays how the events are sequenced, and data flow analyzes and maps each variable and assign a value to each step in the program, that okay, it reached here, then it executed, and that's the information that you get on the screen. Now lexical analysis is scanning each source code in each source code is read from left to right. Source code is grouped into tokens. So the only difference in this one is that it is grouped into tokens, and then based on some similar criteria, it analyzes the common symbols defined in initiating the programming language. And that brings us to the end of chapter number 7.